Assalamu alaikum. Welcome to the class of Advanced Research Methodology. Today we will discuss spin coating method for thin film preparation, the physical vapor deposition technique PVD, and the chemical vapor deposition technique CVD for thin film preparation. Okay, so what is the spin coating? A thin film, basically, before coating, we should understand what is a film, what is a thin film. A thin film is a layer of material ranging from a fraction of a nanometer to several micrometers in thickness. Spin coating is the simplest method for fabricating a film on a substrate. It is a method to apply a uniform film onto a solid surface by using centrifugal force and requires a liquid vapor interface. The spin coating process starts with the dilution of a material to be deposited in a solvent. The solution is subsequently dispersed on the substrate surface. The wafer is then spun at a high speed. What is wafer? Wafer is basically the substrate. The thickness of the film is determined by the spinning speed and also on the time of the spinning, surface tension and viscosity of the solution. Spin coating result in a relatively planar surface. A familiar example is the household mirror, which typically has a thin metal coating on the back of the sheet of a glass to form a reflective interface. So this is the spin coating, and we have to take start from a solution, and the solution is deposited on a substrate, and then the substrate is rotated. It is spun with the help of the spin coater, and finally the film is dried and heat treated to find the final product. So this is the actual image of a spin coater. You see, this is the uh, substrate, and on which the uh, this is actually a holder, and the substrate is placed on this holder, and this holder is then rotated. So this is also an actual image of the spin coater, you see. So what is the phenomena? Uh, the phenomena is that the liquid phase of the material is deposited, is dropped on the substrate, and then it is spun. And when the spinning is off, so we get uh, a deposited material. And sometime by heat treatment, the uh, organic solvent is evaporated. So when this is heat treated, so sometime the heat treatment facility is available inside the machine, inside the spin coater, but sometime it is bring out from the spin coater, and then it is heat treated in a oven or in a furnace. This is another image, another systematic diagram in which a deposition is carried out on in the form of a drop casting, and then it is spun, and due to centrifugal forces acting on the liquid, it is spread over the substrate, and the spinning speed and the time of spinning determines the thickness of the film. So after drying, after heat treatment, the unwanted chemicals, like if there is a solvent, organic solvent, so it is evaporated with the help of heat treatment. So this is a spin coating, and it is utilized uh, everywhere. This facility is available in the Material Research Laboratory, University of Peshawar, and you can deposit the uh, different materials on the different substrate like silicon, like glass sheet, like on any metal surface. So it depends on your substrate that what you use. You can use a conducting substrate, you can use a non-conductive like glass, like semiconducting like silicon wafer, etc. So there is another schematic diagram. The start is from a precursor solution, preparation of the solution, and then it is deposited on any substrate. Here, the substrate is glass slab, and after spin coating, when it is deposited, it is preheated, it is dried. Then, if more heat is required, it is kept in a furnace, and then uh, the final product is obtained, and after that it is characterized by the XRD, by the FTER, or by the scanning electron microscopy. So after that we characterize the uh, material for different properties. All this is about the spin coating method. So basically, the start is from the preparation of a solution, and it can be obtained by sol gel method. The solution can be obtained by sol gel method. The next one is the physical vapor deposition, or PVD. PVD describe a variety of vacuum deposition method which can be used to produce thin films and coatings. PVD is characterized by a process in which the material goes from a condensed phase to a vapor phase and then baked to a thin film condensed phase. So what is done basically, the coating material is evaporated, or it is enlarged from a coating material, and then it is directed towards the substrate, and it is deposited on the substrate. The most common PVD process are sputtering and evaporation. Sometimes it is called thermal evaporation. So sputtering, the meaning of sputtering is the explosive voices, but you can say it's a quick deposition technique. And there is a difference between evaporation and sputtering. We will discuss it later. PVD is used in the manufacture of items which require thin films for mechanical, optical, chemical, or electronic functions. Example include semiconductor device such as thin film solar panels and titanium nitride coated cutting tools for metal working. So what is the sputtering? As I have told you that sputtering means the explosive voices, but in physics, sputtering is a phenomena in which microscopic particles of a solid material are ejected from its surface after the material is itself bombarded by energetic particles of a plasma or gas. This is a schematic diagram in which this is the substrate. You can see the yellow color substrate, and the green color is the material, the coating material. So from where it comes, basically, here is a sputtering gas, which is actually argon, and this argon is bombarded on this sputtering target, and the ions are ejected from this target material. Professor Okay, so the atoms are then directed towards the substrate, and it is then deposited. So this is a physical method, and for sputtering, a sophisticated machine is applied, This machine is available in the NCP, National Center for Physics, Islamabad, in the technical lab. You can utilize it. It is a very sophisticated and very modern equipment. So this is the sputtering machine. Uh, in evaporation, atoms are removed from the source by thermal means. So as we have stated that the PVD can be divided into two types, that is the sputtering and the thermal evaporation. So in thermal evaporation, atoms are removed from a source by thermal means, whereas in sputtering, they are dislodged from solid target source surface through impact of gaseous ions. So this is the uh, actual figure. You can see that this is the sputtering uh, target, and when argon gas is bombarded on this, so the sputtering material is dislodged from this material, and then this is directed towards the substrate by using the potential difference, and it is deposited carefully and in a controlled manner. Okay. This one is the thermal evaporation, and this image is of the Edward thermal coating machine. It is available in the Centralized Research Laboratory, University of Peshawar. This equipment is available there. Thermal coating is another example of PVD where coating atoms are ejected by heating and deposited on a substrate. So here you can see that this is the uh, substrate, and these are the evaporated uh, atoms which are deposited on this substrate. So here the atoms from the target material are ejected by the heat treatment. So when you heat a material, so atoms or ions are ejected from these targets, and then they are allowed to deposit it on the substrate. So here you can see negative and positive. So all it is done by the electric field. So when potential difference is applied against the deposited material, so they are accelerated toward the substrate. The next one is the chemical vapor deposition, CVD. Chemical vapor deposition is a process of chemically reacting a volatile compound of a material to be deposited with other gases to produce a non-volatile solid that deposits on a suitably placed substrate. It differs from physical vapor deposition, which relies on the metal transfer from condensed phase evaporated on sputter target sources. Because CVD process do not require vacuum or unusual level of electric power, they were practiced commercially prior to PVD. A century ago, CVD method were used to deposit a protective tungsten coating on carbon filaments in an attempt to extend the life of incandescent lamps. Today, high temperature CVD process for producing thin films and coating have found increasing application in such diverse technology as the fabrication of solid state electronic devices, the manufacture of ball bearing and cutting tools, and the production of rocket engine and nuclear reactor components. Okay, so what happens during a CVD? Uh, we have reactants gases. CVD is a process where gaseous precursors react to form a solid coating on the heated substrate. So this is a substrate, you can see, and these are the reactant gases which are allowed to come to this chamber, and in this chamber a reaction take place. And what may be these reaction? These reaction may be the pyrolysis, reduction, oxidation, compound formation, etc. So all these can be reactions. You know, the pyrolysis is the thermal decomposition of a material. Reduction mean the hydrogenation. Oxidation mean the oxidation process. And compound formation mean when two ingredients combine to form a single compound. And these are the waste gases which are ejected from the uh, chamber. So what is the difference in the PVD and CVD? In PVD, there are no reaction take place, and the atoms are deposited directly on a substrate. While in the CVD, a reaction takes place in a chamber, and then the compound is allowed to deposit it on a substrate. So in this diagram, you can see that the gases are allowed to go to the chamber, and then there is a reaction take place, and after reaction the material is transported to the surface of the substrate. So this is the film. This is the film, and this black is the substrate. So this is the surface diffusion, and sometime reabsorption of the film uh, precursors. And this is the desorption of volatile surface reaction products. And the unwanted gases are the reaction product which do not need to be deposited on the substrate. They are ejected from the chamber. So this is the main gas flow region, and a reaction take place, and they are directed towards the substrate. They are deposited, and the unwanted gases or products are rejected from the chamber. So this is the main uh, theory of the CVD. So what is the difference between CVD and PVD? These are the precursor gases in the CVD, and chemical reaction take place, and they are deposited on the substrate. While in the PVD, this is the target element material, and they are become plasma by different method. You can say by sputtering or by thermal evaporation, and then they are deposited on the substrate. So in this, there is no reaction, while in the CVD, there is a reaction take place. So there is another difference, that this reaction needs a vacuum, while the CVD usually do not need any vacuum chamber. So all this is about uh, the spin coating, physical vapor deposition, and chemical vapor deposition techniques. So all these are available in the material research laboratory or in the centralized research laboratory, University of Peshawar. So you can go there and you can make different thin film samples. So all this is enough for today. Thank you very much.